Hello, everybody. Welcome to our RAG Hack live streams.
RAG Hack is a free global hackathon happening from September 3rd to 16th. RAG is a technique to get a large language model to answer questions based off your data. We have more than 25 live streams teaching you how to build RAG apps with different Microsoft technologies, plus 10 cash prizes for the best RAG apps in each category. So we're super excited to have you join us for this RAG Hack. And now a word from our friends at Reactor.
Hello, everyone, and thank you for joining us for today's session. My name is Askia, and I am the facilities coordinator at the Redmond Reactor space. Before we get started today, I have a few things I'd like to go over. So if you could please take a moment to read our code of conduct. Basically, we are seeking to provide a respectful environment for both our audience and our presenters. So we do definitely encourage engagement in the chat, but we ask you to please be mindful of your commentary, remain professional and on topic. Today, we will be sharing useful links throughout the chat, so keep an eye out for that. And please keep in mind that this session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. That brings us to today's session. It's scheduled to run approximately for 1 hour, and there'll definitely be time for questions throughout. So with that, I will now turn it over to our speaker.
Hello, everyone. I'm really excited for today's session because we're going to be doing RAG with Vision and figuring out how we can get an application to use a large language model to answer questions about visual data, like images and PDF images and that sort of thing. So this is actually a really fun topic. It has a lot of fun components to it. So we're going to break it down, starting with talking about multimodal LLMs, then talking about multimodal embedding models and searching with those, and then finally putting those together to be able to do RAG with Vision to answer questions about images. So let's start off with multimodal LLMs. So we have a couple large language models that are multimodal that you can use on Azure. So we have a few of them from the OpenAI, and these were the first ones we had. So GPT-4o and GPT-4o mini, they can both accept either text or image as input, and they can also accept both at the same time. If you have a question and an image, you can get it to answer on that. So that's the GPT-4o series. So GPT-4o is the more powerful version. GPT-4o mini is less powerful but cheaper. So hey, that's pretty good. And then Microsoft also, for Microsoft Research, has the Phi 3 Vision model. And that one can similarly take images as input. So these are the multimodal LLMs that we have right now. And, it's really cool that they can take text or image. In the future, hopefully these multimodal LLMs will be able to also output image and also be able to accept like other kinds of modalities, maybe like audio or video. So we'll just have to see, how things go with that. But hopefully we'll, be seeing those sort of things in the future to enable even more powerful applications. Now, in terms of where you can use these from, if you're trying to use the OpenAI ones, you can use them from Azure OpenAI. That's where you're going to use it when you're in production. Of course, you could also use it from openai.com if you, didn't want to go through Azure OpenAI, but me being from Microsoft, I'm going to recommend Azure OpenAI. You could also use them when experimenting from GitHub models. So GitHub models is a way that you can use these powerful models for free for a certain amount of requests every day, and you can use them just with having your GitHub account. Now, this is a waitlist only thing right now. So if you're not yet in it, do go ahead and get in it because it's really, really sweet. So you can get access to all of these models here. So you can see we've got the OpenAI ones. There's Phi 3. I don't see the Vision one on here yet, but hopefully it'll be here soon. So you can just play around with these and, just by having a GitHub account. So definitely sign up for the waitlist for this if you haven't signed up for it already. And yeah, so there you go. So we've got several options, for Phi 3, if we did want to use the Vision, we could use it from the Azure AI model catalog. And you can kind of go to ai.azure.com, click on model catalog, and then you go to Phi 3 Vision instruct, and you can make a deployment of it. And you can also try it out here in the playground. And you can see that this playground here does have you know, an optional image upload. So I always say describe this image because I never know what I'm even uploading. There we go. There we go. There's the streams we have for RAGAC. So I am asking the model to describe this image. So this is the kind of thing we can do with our current multimodal LLMs, is send it both text and images and get these really good responses where it has very accurately described this image and mentioned everything, all the text on it, and when submissions are due, September 16th. And it did a really good job. So we have a similar experience with Phi-3 Vision as we have with the GPT-4o models. All right, so those are the multimodal LLMs that we can use. Now let's see how we can actually use them for Python. So I'm going to use this repo here, and we're going to put the ACA in the chat so you can access it. And this repo has notebooks as well as an application. So I'm going to start off with the notebooks so that we can see how to use these APIs from Python. So here I'm in the Chat Vision notebook in the notebooks folder. So, the first thing I do is load my environment where I configure which model I'm using and what host I'm using. So here you can see in my environment file, I can either point it at GitHub or Azure or even local. So here I'm going to use GitHub models, and I'm going to use GPT-4o mini, no, just GPT-4o. I mean, we can go ahead and change this to mini. I can change that here, whatever I need to do. And then I set the endpoint to the GitHub models one. So that's what it's going to be using here. So we just create the OpenAI client and we point it at the GitHub models endpoint, and we pass in our GitHub token as the key. So this is a nice way of experimenting. Of course, when we go into production, we're going to be using Azure OpenAI and going down the OpenAI path instead. But just when we're using a notebook, it's easy to use GitHub models. Then I can go ahead and send an image by URL. So what we have is the messages that we send to the LLM. And so here I have a user message, and this user message typically only contains text, but now it can be a list of Python dictionaries, and each of these dictionaries actually has a type. So this one has a type of text. So this is text that we're sending. And then this one has a type of image URL. And we actually send along the URL here, and we can even include some additional information about the URL in that dictionary. So we can, just send a lot more than we could before when we were limited to just text. So now we're sending both the question and the URL to the image. And then we send it to the model that we're using, and we set the temperature, we send the messages, and print out the response. So let's go ahead and run this. It says it is not a unicorn. It is a bovine animal. I should show you the picture that we're looking at here. We have a lot of debates in our households about unicorns, since I do have a 2-year-old and a 5-year-old. So pretty much life is unicorns. And as you can see, this is not a unicorn. Okay. Great work. Now let's see how we can send an image by data URI, because this is only going to work if it's a publicly accessible image. So, it does work for Wikipedia images because they're public, but a lot of us are going to be developing applications for our own internal data. And so we don't want to be like sending a link to a public URL. Instead, we want to be able to send, some data. So what we're going to do is open the image, convert it to a base64 encoding using the base64 module, and then return that as a base64 data URI. So it starts with data, :image/ping, base64, and then the base64 encoded image. So that's the way that we can send any arbitrary image to the API. So this time I say, oh, how could I make this into a unicorn? And for the URL, I'm actually going to send the base64 encoding instead of the absolute URL. So let's go ahead and try this out. And it is processing. All right. And it says creating a unicorn would involve some creative edits: single horn shape, mane and tail. Yeah, lots of things. Let's just get it to name this animal. Cute name for this animal. Here we go. And it's sending along again. Horny hooves. Great. LLMs. So there we go. So that is how we can send, send images to a multimodal model. I see a question from Sarah. Is there a quality trade-off in using the base64 encoding? As far as I know, our base64 encoding is actually including all the information. Like, I don't think this is a lossy, or we talk about like, lossy compression versus lossless compression, right? So I think in this case, we're just, we're taking the full data and encoding it. So this would be a lossless compression. So I think the question is just, how large of an image you're sending, because I'm not sending along a very large image right here. Let's see how big was this image. Okay, 1470 by 877. So that's decently large, but if you were doing something really high resolution, you might send even larger. There is a parameter. Let me see if I can find it. Chat completion, API, image URL, resolution. So you can like tell it what, how much detail to use. And so that's the trade-off. Let's see. I'm trying to get the actual reference for it. Let's see if this is getting explored. Yeah, the vision guide. Okay. And detail. Okay, detail. All right. So by controlling the detail parameter, you have three options: low, high, or auto. You have control about how the model processes the image and generates its textual understanding. By default, it'll use auto, and that'll decide whether to use low or high. But if you you're talking about having like a blurry image or something, you would probably definitely want to use high. And so this will, this is the most amount of detail it can possibly send. So it'll actually end up sending, breaking up that image and into 512 by 512 tiles and sending it on. So that's where we do have a trade-off, right? So I've just been using auto, but if I wanted to, I could specify the detail high. And that's why image URL is a dictionary, because you can specify the URL and you can also specify the detail. That's a great question. Joao asks, could you send the image encoding from the transformer? So I assume you're like running transformers like locally or something. That's a good question. As far as I know, the only examples that I've worked with and seen are sending either a URL or a base64 encoding. Here you can see, it supports ping, JPEG, WebP, and non-animated GIF. So I don't think that you can send any other sort of format, right? Because that is what I'm sending. I'm just sending it as a, a base64 URI, but these are the file types that it does support here. And there's a question from Nam. Can it analyze visualizations like line graphs and bar graphs, especially when different colors represent elements of the graph? Yeah, so let's find Wikipedia bar chart. Let's see. Grab one. Okay. Oh God, that's a depressing one. Okay. Let's see. CO2 capture. All right. Let's try this one. Let me get the image URL for this. Use this file on the web. File URL. Okay, let's see. That looks like a good one. Oh, it's an SVG. I should be able to get the ping for it. Let me go back. Let's see. I think it's only that one. All right, let me try and find. Oh, that's also depressing. A lot of charts here are kind of depressing. I think this is going to be an SVG as well. Let's see what this one, SVG. Then can we do open in media viewer, other resolutions? Haha, I got a ping. All right, very good. Okay. So let's go ahead and ask it to answer a question about this, right? So you're asking about like colors and regions. So are we losing more trees in tropical, or what zone are we losing the most trees in? I guess every chart is depressing. Well, yeah, so we are losing the most trees in the tropical zone as indicated by the dark green section of the bars, which is the largest compared to the other zones. So here you can see, basic chart processing, but generally what I've seen is that, yeah, it is actually pretty good at chart processing, at least the GPT-4o models that I've worked with. And I think it might actually like specifically have had, a lot of charts as part of its training. That's generally like a big use case that we recommend for it, as opposed to like photos. You can also ask questions about photos and we have examples of that. But in terms of RAG, more of what we've been recommending is stuff like charts and graphs and that sort of thing. But it's definitely something you want to experiment with to see what's its limit. Like how good is it at looking at numbers and stuff like that? Like, if you asked for exact years and exact the axes and stuff like that. So I think it's something that we need to explore more and see. So try it out with the charts that you're imagining and see how well it works for what you kind of questions and the kind of charts that you want to use with it. All right, great. So the other thing we have in this repository is a full application that is a little chat plus vision app. So I'll go ahead and run that app. Open this up here. All right. So this has a really basic front end where we can set the temperature, upload an image, and ask a question about the image. So, I'll go ahead and download that image again. Let me download this one locally. Download. Okay. All right. And let's go upload this one. Downloads. Okay. Here we go. And say, which zone has the least tree loss? Okay, so we're asking question about, so zone with the least tree loss is the boreal zone. This shows least amount compared to other things. Let's say in what year was the greatest tree loss? Let's see how it does with the x-axis here. The greatest loss occurred in 2016, which I think is probably correct. The axes don't have exact marks, but yeah, I think this is 2016, 17, 18, 19, 20. Yeah, this is 2016 as indicated by the most negative value on the graph. So here we have a basic application for being able to answer questions about the images. And it's basically, it's just creating a front end for what we were able to do in the notebook. But you can start to imagine that you can, build really helpful applications specific for domains that maybe have built-in prompts or suggested questions that help people with, with some scenarios, right? And we have a bunch of scenarios in the, notebook that people have used the vision for, right? So stuff like insurance claim processing, deciding whether a claim is probably valid, helping someone with their appliances, helping folks who are vision impaired, automated image captioning, and analyzing tables is also another thing it can do. So there's lots of really compelling use cases for these multimodal LLMs. I see a question from Karthik. Can we train the model for outputting reference style image based on the input training video or some reference style images? So this model is only outputting text. So I was saying in the future, maybe these models will be able to output images. And I think they did even do a demo of that at OpenAI Dev Day last year. But in the APIs, at least, these images, these models are currently only outputting text. If you want a model that outputs image, as far as I know, your options are basically like the DALL-E models or, other sort of diffusion models. And I don't actually know offhand whether you can fine tune those image generation models or not. So maybe somebody in the chat who's worked more with the image generation models can comment on that. I generally only work with the text generation models right now. So I'm not as familiar with those options. Good question, though. All right. So there we have the app that I showed, right? So we ask a question and it gets sent to the back end, which sends it to LM, and then we get the answer and send it to the front end. So if you do want to develop an app like that, you can, start from that repo and build on top of that. So now let's talk about multimodal embedding models, because this will enable us to do search on images as well. So we're going to use this Azure AI Vision API that uses the Florence multimodal embedding model. So what you can see is that we can take an image and then send it to the API and then get back a list of floating point numbers. And this is the vector embedding that represents that image in this particular embedding space. So this is a multimodal embedding space. Every vector in it has 1024 dimensions, which means it's a list of 1024 floating point numbers. And the fact that it's multimodal means we can both generate vectors for images and for text, right? So we could, generate a vector for this image and get this one, and then generate a vector for this string of text here and then get this one. And then we can, actually compare those vectors to each other because they're in the same embedding space. So that's what we mean by a multimodal embedding space, is that embedding space can represent both text and image inputs in the same space, and that they can be compared and searched together. So how do we use that from Python? So here we have some, example code. This is just sending requests to the API. Let's actually look at a full demo of this. So I'm going to go to another repo, and we'll put this link in the chat. It's aka.ms/AI-tour/ it says Azure Search. Let me get you a better one than that. It should be image search. There we go. All right. Let me give you this one. This should do it. Image search should go to the right place. Yes. All right. So you can follow along with that one if you'd like to follow that URL. All right. So going into this notebook here, the first thing I do is that I'm setting up the Azure AI Search SDK. And that's because this is where I'm going to store the vectors in this case. So you could use any sort of vector store, anything that's capable of vector search. So, here I'm using Azure AI Search. You could do Postgres with PG Vector. You could do Cosmos with vector, right? Anything that supports vector search, you could use to build a, multimodal search application. All right, so let me set that up here. Okay, and then this one creates the search index, right? So you think of this as creating, like a database table. So here I'm storing embedding, which is a vector column, and it has 1024 dimensions. So it's going to store embeddings with 1024 numbers in them. And I'll use HNSW, which is an algorithm for efficient vector search. And so it just says every time I search this embedding field, make sure you use this efficient vector search algorithm called HNSW. So I create that client, and I actually already created it. So that's why there's a little error that says it already was made. So that's cool. And here, what I'm setting up is the Azure AI Vision SDK. So I have a function here that can take an image file and then send the data for that image file to the SDK and get back the vector. And then I have another one that can take text and send that to the vectorized text endpoint of the SDK and then get back a response. All right, so let me run that. Okay. All right, so now I have my connection set up for Azure AI Search and for Azure AI Vision. So the next step is to actually vectorize all of my images. So I can run through a bunch of images in this local folder here. And these are all like things that I made when I lived in the woods. And I kept collecting things and doing wood burnings and all sorts of things. So this is just a collection of, like wooden things and stony things and whatnot. And so here we go. So I go through them and I create the image embedding, and then I store them in the Azure AI Search Index. Now, I already did that because it does take a few minutes, so I'm not going to run that one again. But they are already in that index with their ID, their file name, and their embedding. Now that the index is set up, I can do a search, right? So I have separate images, like my query images that are not in the index. And so I can search using them. So here's an example image here. This is of a like candle holder that looks kind of like a beach. And what I do is get the image embedding for that and then search the image index with that image embedding. And then I can look at the documents that come back and I can look at their file names, but we didn't search the file names. We only searched that embedding, which is of the image. So what really matters is what do they look like? So the question is, for this input image, when I do a vector search with it, what do I get back as the closest image? So go here. And what we can see back is that the image is actually of the same candle, but at night with, lit up. So it did a really good job, right? These are technically like fairly different images. This one, it's got a light background and it's from different angles and all that. But it just, it knew that these were actually the two most similar things. So that's like really cool, right? We could try that with a different input image. So you can start to imagine like you can let people like upload things and find things that are similar, maybe find like a similar product, similar t-shirt, that sort of thing. Okay, so let's look. So this is like a necklace out of driftwood, right? So I'm going to search for that. And then, ooh, what's this? Oh, now I'm unauthorized. Did my token just run out? All right. Okay. Always likes to kill my token in the middle. All right. So let's move on. I hope the next one is still going to work. All right. So I'm going to try and get a text embedding. Otherwise, I'll have to do a relogin. Okay. So that time it's working. So now I want to demonstrate is that since this is a multimodal embedding API, what I should be able to do is get a text embedding and use that to search for images, right? So if I search for Lion King, then I can look and see that the top result is actually a wood burning that says Hakuna Matata. And this, when I saw this, the first time I saw this, it just blew my mind because it was like, what? You found the fact that my wood burning says Hakuna Matata and you related that to Lion King? That's crazy, right? Like all it knows is that, in its embedding space, this image is the closest to the Lion King vector, right? And if you don't know, Hakuna Matata is a song from the Lion King movie, right? So I just think this is so cool, right? We could do other things, right? There was like one piece of driftwood that always reminded me of a mushroom, right? So if I look at that and then I look at the result, we see that it found the necklace that looked like a mushroom, right? They're very, very visually similar. There's like, the driftwood would always resemble things, right? So there's also one that kind of looked like a knife, right? That kind of looks like a knife. I also think it looks like a horse, but if I search for a horse, I tried this earlier today, horse. And what does it think is the most like a horse? For some reason, it thinks this one's the most like a horse. I guess it kind of is too when you look at it. So I just think it's really, really interesting. And I think this can enable, people to be able to find things that are visually interesting to them that they might otherwise have a hard time searching for. Okay, so now I'm asked, do the query embedding model and the image embedding model need to have matching dimensions for them to work together? That's a great question. That yes, and they need to be the same exact model. So it's not only that they have to have the same dimensions, they need to be exactly the same model. So I used the same embedding model, right? So, there's two different endpoints. There's two endpoints, right? It's vectorized image and vectorized text, but these are both going to the Florence model, and the Florence model is for Microsoft Research. These are both going to the Florence model. So they are returning vectors that are inside the same embedding space. So need to be the same number of dimensions and the same exact model. And so that's a really important point. So when you are setting up your, Azure AI Search index or your PG vector, column or whatever, however you're storing your vectors, you should really describe accurately exactly what model you're using for those vectors. Because if you just look at the vectors, it's hard to look at a vector and just know where it came from. Like, yes, this list of floating point numbers, I know exactly where it came from, right? And you don't, right? So I have actually started, like something I've started doing recently is like, when I create an index, like actually just saying like embedding, Florence, right? Let me write like Florence, right? So trying to make it super clear, or maybe putting in the metadata or something like that. But try to make it really, really clear what model you used to make sure that anyone who's querying that is also using the same model. Otherwise, you're going to get really, really weird results. Okay, and Zhao asks, can I expand on the different search algorithms when I'm defining the vector search retrieval? Yeah, so here I'm using HNSW, and this is also the algorithm that I use when I'm using like Postgres with PG Vector. Generally, you have like several options, right? So vector search options. We can do brute force, which means literally check every single vector to every other vector, and that would actually work fine in this case because I had such a small number of vectors. But once you get into thousands or even millions, you're not going to want to use brute force, at least not when a user-facing application, right? Then there's HNSW, which is hierarchical navigable small worlds, yeah. And then there is FICE is actually related IVF, inverted file. That one's supported by like PG Vector. I don't think it's supported by AI Search yet, but there are some use cases where IVF might make sense. Hierarchical navigable small worlds is really nice because it's also easy to update, right? IVF is harder to update. HNSW can do, updates much more easily. So that's why a lot of people are using HNSW, because they can, just if they need to delete something, if they need to add something, it can just update that index fairly easily. And then there's another one you'll hear about, especially from, some of our talks here, which is DISC ANN, where the ANN stands for, approximate nearest neighbor. And we have that, I think that's what Cosmos is working, using right now. And it's, it takes advantage of hardware. It's using hardware to optimal use of hardware in order to get really good performance. So I'm not an expert in that, but we did have some talks that mention that. So these are generally the ones that you're going to see used the most, especially with Azure stuff. And some of our services support all of them, some support only some of them. But I think eventually we'll probably have all the options for everything, just to give people more options. So yeah, you're going to want to use some sort of approximate nearest neighbor algorithm, like one of these three. You're going to want to use that once you have a significant number of vectors, so that the search step is fast. All right. Great questions. So yeah, here's asked, what about Azure SQL? And we had the presentation from David on Azure Search, Azure SQL earlier this week. And I believe he talked about using maybe DISC ANN. So I would go ahead and recommend going back through that presentation to see. Let's see if we can find it really quickly. Oh, I went too fast there. Okay, vector search, Azure SQL vector EIP announcement. Let's try that. And I'm just going to search for DISC ANN to see if they mention. Okay, they didn't mention it. So I actually don't know I'm not sure what algorithm they're using. They might, actually, I do remember asking them. I think they have some way that they have optimized this so that it's a fairly fast search thing, but I don't think it's technically a kind of index yet. So I think right now they have some sort of optimization so that they're getting pretty performance from it, but not using one of the, approximation algorithms that I talked about. Great questions. And Bill asked, do the models have to be compatible or do they have to be exact? That's a good question. I guess I don't know if we actually have a practical version of Florence version 1 and Florence version 2 and whether they have the same spaces. My assumption is that, if the model changes, you're going to recalculate the models, recalculate all the vector embeddings. We'll see. Maybe there are some sort of small tweaks, but I guess I can't imagine a tweak where you wouldn't have to recalculate the embeddings. Because imagine just something changes in some part of your brain. it kind of changes everything in a way, I would think. So I don't know. That's a good question. Is there's any sort of update that can happen to an embedding model that wouldn't require recalculating everything? I feel like it always would, but I could be corrected. Great discussions. Okay. All right. So as you can see, yeah, we can use these this to be able to do vector search with multimodal embeddings, right? So if we have an image, we send it to vectorized image. We use that to do the vector search, and we could get back related images for that, right? These are crocodiles these are actual photos I took of crocodiles when I was in Costa Rica, and they were very scary to me. So these are actually crocodiles. But, you know, if I search for alligator and send that to vectorized text and do a vector search, I'll get back these pictures of crocodiles because that's the closest thing in, you know, in its embedding space, right? So we saw that vector search. I also have this application that does an actual front end for search on images. So if you are specifically looking to build, you know, image search into your app, like for retail or products or, you know, something like that, you can try this application, and we'll put the link in the chat at aka.ms/AI search-images-app. And let me just run that so we can see that running here. Let's see. Oh, it looks like I've got it running. What port am I? What port am I on here? Okay. All right. So here it is, and I can search. We'll start with something basic. Okay, so we got a bunch of nature things back. What about animals in love? Let's see. Oh, it's so cute. What about something completely different? Peanut butter jelly. Okay, so one thing you do have to keep in mind with vector search is that you will get back relevant results if there are relevant results, but if there are no relevant results, like for peanut butter jelly in a nature's thing, you will still get back results. Now, generally the vector search score will not be as high. And so you might be able to like set a threshold, but you definitely want to keep that in mind, is that, you know, you will always get back results. And maybe that's good. Maybe you always want there to be some sort of results, like, you know, just so the users have something to look at. But it also could, you know, reduce users' confidence in your search if they feel like what they're getting back is completely irrelevant. So what you can do is like look at the scores of, you know, the search scores of what comes back, and then, you know, trying to figure out if there's a good cutoff and say like, okay, at this point, you know, it's just not finding anything useful, so we're just not going to show those results, right? So you'll generally have like a similarity score, a search score, you know, for all your results, and you could try to make a threshold based off of that. But, you know, usually it's pretty good. And the cool thing is that, you know, we just get internationalization support for free. I guess there's no monkeys in this data set. Let's try like elephant. Okay, and then elefante, Spanish. Okay, good, right? So that'll just work. What about Lion King? You see, I really like Lion King. Okay, those look like the Lion King. What if we search in Spanish? And those also look like the Lion King. So, you know, this is really cool, is that you get some things for free, right? You get translation for free. You get spelling correction for free, right? Like, let's say elephant is pretty hard to spell, right? Font. Okay, we still get back elephants. It doesn't have any issues with, you know, realizing that a misspelled elephant is the same as a correctly spelled elephant. Now we're just looking for animals. Moose. Do we got a moose? We got a moose. We got a moose. All right. I think it's so cool. I mean, luckily, I think a lot of our Photos apps do have these days. Like, I think Google Photos basically is doing something like this, because I am starting to be able to search Google Photos for things, right? Because it's like, oh, I want to find like all the pictures of the caterpillars I took, and then get them back. So here, these aren't my own images. If I was searching my own images, there would just be so many caterpillars because I just spend all day taking photos of caterpillars. It's a problem. But yeah, I think it's really, really, really fun. And I think there's a lot of really good use cases for it. I do use this sort of thing all the time because, you know, I was saying I do like to raise caterpillars and native plants and stuff like that. So I'm often taking pictures of nature, of plants outside, and trying to identify them. And I think they often use similar models. Oh, I think theirs might be more specifically trained for, you know, for plants and animals. All right, cool. So now we have seen multimodal embeddings and multimodal search. So that means we can move on to RAG with Vision, which was the promise of today. So let's see what this is, what the RAG flow is going to look like. So we'll get a user question, right? So here the user asks, is there any correlation between oil prices and stock market trends? All right. And then we take that user question and we embed it using both a text embedding model and our multimodal embedding model. And in this case, we're actually using 2 different models. And I guess we maybe could, we could have actually used the multimodal for both, but in this case, so we're actually, what we're doing here is we're adding multimodal support to an existing RAG application. So this was a RAG application that already had a normal RAG flow that was already doing text embeddings. And so we're adding support for additionally being able to search images, image versions of the documents. So we convert those, then we do a multi-vector hybrid search. So we search our search index for the original text query, doing a keyword search, and then for the text embedding and for the multimodal embedding. So we're searching all of these things to try and get the best results. And we get back both matching text, and this is the text that we embedded using like just a standard text embedding model. And we get back matching images, right? So these are the images that we embedded using the multimodal embedding model. And then we send the original user question and the text and the images, all of that to the multimodal LLM and say, hey, please answer this question according to the sources. And we get back a response. So this is the flow that we are using. And this is implemented in our most popular RAG sample, which you can find at aka.ms/RAG chat. And you can get the specific guide for how to enable vision at aka.ms/RAG chat/vision. It is an optional feature that you have to deploy. So if you are interested in that, you do need to follow those steps. And I'll go ahead and show you it. Let's see. All right, so it's working here. And I'm just going to make sure we're using the vision feature. And I'll do that question that we just saw. And of course, here we go. Let's see. Did it log me out? It might have logged me out, in which case I'll just, yeah, it did. This always happens, is that it logs me out during my demos, but that's fine. I have it deployed here as well. So we should be able to do the same thing. Okay. All right. And this is generally going to be a little bit slower than our usual request, since this is involving, extra models, extra steps, and it is using GPT-4o as opposed to GPT-3.5 Turbo, which is going to be a little bit slower usually. So here we can see, yes, there is a correlation between oil prices and stock market trends, right? And then if we look at the citations, like what it used here, what we see is that it did get some text, but it also got tables, and it got line graphs, and it got this line graph here, right? And so here in this case, for this question, it answered using the table. So it extracted it from the table. We've got other questions that, it pulls from these charts instead, but you can see here it's referencing 2023-6. That's this table here. Let me do one that, let's see, it pulls from one of the other charts. Let's see. So yeah, this time it's pulling from -7. So that's page 7 of the financial report. So if we look at 7, that's this one. So this answer was based off this line chart here. So it gets a mix of both the text and the image. So basically what we've done for this application is that this was an application that already knew how to do RAG on PDFs. And now we made it so that, like, okay, well, if your PDF has images inside of it, we can also send those images to the LLM as well. So these are actually images of PDF pages that we send to the LLM. All right, let's talk a bit more about how this worked, right? So when we get the user question, we are doing a text embedding with OpenAI's text embedding model, because that's what we always do. But then we're also doing an additional text embedding, multimodal embedding with the AI Vision API, and sending both of those to Azure AI Search. So if I look at, let me look at the thought process here. You can see in our AI search index is that we've got multiple fields. We've got the embedding field, and that's the field that we always had, and that would be the embedding of any text that we found for that PDF page. And then we have the image embedding, which is the multimodal embedding of the image version of that page. So you can imagine each of these like representing a page from the PDF and having an embedding that represents text and an embedding that represents the image. And then sending those to AI Search, getting the results, and send them to GPT-4o. So we had to add more steps to our data ingestion. So first I'll show what our data ingestion looks like for normal PDFs, right, before we added this feature. So, first we would upload the documents to Azure Blob Storage. Then we would extract data from the documents using Azure Document Intelligence, which could, pull out the text and even OCR images in there. Then we split that data into chunks. And then we vectorize those chunks using the text embedding models from OpenAI. And then finally store them into Azure AI Search. So that was our process for textual PDFs. Now, in order to add this vision feature, then we also do this additional ingestion steps. So we take the PDF and we split the PDFs into pages. And for each of those pages, we generate an image of that page. Then we upload the images, each individual page image, to Azure Blob Storage. And for each of those images, we create a vector of the image, and we store, both the file name to that image and the vector of that image in our AI search index, along with the other stuff we had from the other steps. And one thing to note is that when we generate those images, we have to actually bake the file name into the image, because we're trying to get citations, right? Do you notice how I have a citation here? And that was something that we asked the LLM to do. We said, hey, you have to cite your source, right? But if your source is an image, how does the LLM know what to cite? It doesn't, there was no file name that we send in. So the only way that we can send in the source is that we actually bake it into the image. So we literally, get the image of the page, and then we use Python's image library Pillow in order to put a white banner at the top and write the source file name at the top. And then we tell it in the system message, we say, hey, by the way, you can find the file name in the top left corner of the image with these coordinates, and this is the format, right? So we have to tell them how to find that citation, and that's how we can get citations out. So this is the trickiest part of our process here. And I don't know if anyone's figured out a better process for getting citations, but being able to know where your answer came from is really important. That's one of the big benefits of RAG, is that the user can say, oh, okay, cool, that's where your information came from. And then I can go and click and look specifically at that information and confirm that it actually worked, right? And so this was our approach to being able to get it to reference that file name. And then we made other changes to the system prompt as well, just to say might have graphs and tables, you can get what happens if you get the same answer from text and image source, right? There's various things that we put in the system prompt, but the big change was having to bake that citation into the file name and telling it how to find it. Martin says that's much cleaner than what I've been doing. Oh, thank you, Martin. But there's probably benefits to what you've been doing too. So this is sort of thing, this is why it's an optional feature and almost basically like an experimental feature, because I know that it's not perfect what we're doing, but it is also pretty cool, and it can get you a lot of the way there. So, we need to find out what other people are doing. We need to find out how this is working for people so that we can, improve it. There was also a question before, was what's the re-ranker model used here? Let me see. So when we do it Azure AI Search, we are using semantic ranker that is built into AI Search. And it is a re-ranking model that is the same model that's used by Bing. And basically it takes the user question and it takes the results and it re-ranks them according to the user question. Now, in this case, the results also includes images. And I actually don't think it can particularly reason about the images. So I actually don't know how well the re-ranker really works if you only had images back. I don't think it would particularly know what to do with them, right? Because it's generally only re-ranking based off of text, right? Not based on images. So yeah, the re-ranker isn't particularly optimized for vision, and might even be somewhat incompatible with it. I mean, it's definitely compatible with it, and we're still using it because we also have text as well. The text often describes like what the chart is of, so it's still helpful, but the re-ranker doesn't know how to reason about the image itself. It's only looking at any text content that came from that PDF page. So Joao asked, couldn't you do it in the metadata? So when we're sending it, let me show you what we actually send to the LLM, right? So we say, here's the user's question, compare the impact of interest rates and GDP. And then we have the text sources. And so that's all here, sources, 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 sources. And then we have individual, dictionaries for each image URL. And as far as I know, all we can put there is the URL and the detail. We don't have a way here of putting the file name. If I'm wrong, then let me know, because maybe there's something easier we could be doing, which would be great. Because we're sending multiple images. If we were only sending one image, then we could just say, hey, the image is named blah, and we could put that in the text. But we are sending multiple images. And, as far as I know, we don't have a way of saying, what the file name is for each particular image. It'd be cool if we did, though. So, please let me know if there are ways to improving this. Yeah. It'd be really cool if we could make it easier, since that step is pretty much a pain. Now, as I'm saying, like, this is not a perfect system yet, right? So definitely one thing we've noticed is that in this process, when we get a PDF, we take every page of the PDF and we generate embeddings for every single page and we upload those embeddings. But if you have a PDF that has some pages that are like almost entirely empty, like there was one customer who had a PDF page that was entirely blue, right? It was just like a blue folder cover. And that blue folder cover was showing up in so many searches because apparently the concept of a blue color was considered similar to many other things in the vector embedding model space, right? So you really want to make sure that when you are generating embeddings for anything, whether it's text or images, because I've also had this problem with text. If you accidentally generate an embedding for like a string of white space, you will find that string of white space showing up in your vector search results a lot. So generally, whenever you're going to generate embeddings, you want whatever you're embedding to be highly meaningful, right? So do not accidentally generate an embedding for nothingness or something like nothingness or blankness or emptiness, because that embedding will actually can actually be considered very similar to lots of query vectors, right? So we thought about different, approaches around this, right? So, making like you could use an LLM at the ingestion phase to decide when to generate an image embedding to say like, oh, there actually is something interesting on this page that's kind of visual. So we're going to, ingest it. I think an LLM would be pretty good at making that decision. You could also use an LLM just to describe the images. And there you wouldn't even need a multimodal embedding at all. You could just have the LM describe the images and just add that image description to your text field. That would be a completely different approach, which actually could work really well depending on your search case. Because remember, we have two steps here. We have the search step and we have the reason step, right? There's many different ways you could do the search step. So here we're actually searching image embeddings, but you could also be searching descriptions of images too, right? So that would be another option. So yeah, so different things we've considered, something for you to keep in mind depending on your use case. The other thing you might want to do is like here, I'm only, asking questions with text, but we can, let the user upload an image and the user could ask a question with an image too. That would be a nice, additional feature in this and could enable more questions, right? Really bringing together the two demos that I showed. And yes, there are other considerations. I actually wrote up a blog post, that basically is basically a blog post version of this talk. And, I talk about these considerations here. So, go through this post as well to get, everything we just talked about, and maybe a little more details too. And as I was saying, like, it definitely is something that we're learning about. There's different ways of doing it. So we, love to hear other approaches. We like pull requests to our repo as well, from folks who have done something that's working really well for them, and just generally want to learn from the community of folks doing RAG on vision. All right, so let's see. That's my last slide. So let's see if we had some other ideas here. So Joao was saying, yeah, you could store in the vector store metadata. Yeah, I think the big problem is just figuring out how to send it. So we do have it in the vector store metadata, right? We have it here. The question is how to send it to the LLM when we're sending multiple images and they each have different citations. Because I don't think we can say like image number 1 is this and image number 2 is this, because I don't know that he necessarily knows, the images in order. So, it's a question of trying to figure out how to give a citation when this is all we have to work with. As Martin says, clean your data, garbage in, garbage out. It is so true for vector search. Like, so many of my issues are just, oh, I accidentally generated an embedding for something that was not meaningful, right? So it's really, really important. So that means like, like when I did, like I have a RAG on my blog, right? And so one thing that helped was that, when I processed it, I removed, the footer of the blog, and I removed the header of the blog, because the footer and the header were both not meaningful and were noising up the vector search, right? So yeah, it really helps to do some sort of pre-processing or some decision-making during your ingestion phase to make sure that you are only generating embeddings for meaningful things. Any other questions? We've got 3 minutes left. If you have additional questions as you're watching this, there is a discussion thread, and we'll put the link in the chat. And yeah, it'll be this discussion thread here, discussion number 64 on the RAGHAP repo. So here you can get the recording, which already exists, magic, and also the PowerPoint slides. And those have links to all the repos. I'll go ahead and add some more links just here too, just for easy clicking to all the demos we showed. And so you can go through them. And if you have any additional follow-up questions or ideas, you can go ahead and put them in this discussion thread. Cool. All right. Well then, thank you everyone for the great questions and engagement in the chat. It's, I think, a really, really interesting topic, and one that could be really, really powerful. So I look forward to us all acting on it together.
All right. Thank you, Pamela. That was excellent. And thank you all for joining. We really appreciate your feedback. So if you would like to share that, we have our survey link and our event ID code, which is 2336. Once again, we appreciate your feedback. We take everything into consideration, and we'd appreciate it if you had something to say. But with that said, we are wrapping up today. So we will see you on our next episode. Thanks, and have a great rest of your day.
Hey, everyone. Hope you enjoyed today's session.
If you aren't registered yet for RAGHAC, you can register now at aka.ms/raghack/register, and you can introduce yourself on our forum. You can start hacking either by looking at one of our code samples or just starting from scratch. If you have any questions along the way, feel free to post them in our GitHub discussion forum, and you can also attend live office hours in our Discord. Once your project is ready, make sure to submit it before September 16th at 11:59 p.m. PT to be eligible for our cash prizes. And of course, make sure to join our upcoming live streams to learn more about RAG. Thanks for joining.